Hello, everyone. Welcome back to the AI tutorials. It's AI in very simple language, which a common person can understand. Today, we are going to talk about bias and variance. What do they mean? How to compute them? How to fix them or address them? We're going to talk about that. So, bias and variance are two fundamental concepts in machine learning and AI. They both impact the accuracy and generalizability of your models. Like, how much can you generalize your models? How accurate is your model? Okay, they impact both. Let's see what each one is. First, what is a bias? Bias is underestimation of the true relationship between feature and output. It's like seeing everything through glasses of wrong prescription. It's like everything is looking fuzzy, which means your model cannot see or predict the actual relationship between the features and the, the value that you're going to predict. Okay, the predictor. High bias, it means model is making simple assumptions that miss important patterns in the data. So which means you are not feeding or giving it the appropriate data which will help the model identify the relationship between it. It can happen due to several reasons because you're using very simple model. Okay, like you're giving it just one feature and asking it to predict the predictor. So the model has only one feature to base. So what happens? High bias leads to underfitting. So wherein the model performs poorly on both training and unseen data. Okay. Variance is opposite. It's think of it as models sensitivity to small changes in the training data. Now, this is opposite in the sense now you make the model much more complex. Okay, so now model is unable to determine what which feature impacts the most the value that you want to predict. So there is too much noise in the data, too much irrelevant information. Okay, things that are not needed, you're still giving it. That is the cause of the variance. It can happen. So what is the cause? It can happen due to very complex model, many parameters that you don't need it. Training for too long or having noise or insufficient training data. Now, what variance leads to overfitting? Bias leads to underfitting. Overfitting, where the model performs well on the training data, but in the testing, okay, or unseen data, it fails because it's unable to identify the true pattern or the true relationship between the features and the value that you want to predict. Now, there is a fundamental trade off between bias and variance, right? Because they are both related. If the model is too simple, you'll have a high bias. If the model is too complex, you'll have a high variance. So, thus, you need to find balance. So, reducing bias often leads to increase in variance because again, so you need to find a balance. You cannot make the model too complex, neither you can make it too simple. So basically, first in your mind, you got to be clear in the relationship of the data and then train your model accordingly. Give that data to your machine learning model. So in your mind, you should be clear that which features actually have the most impact on the predictor. So let's say for a very simple example, if you want to predict whether it's going to rain or not, you should know what factors actually will help You yourself, not the machine, will help you. So let's say if you were a weather person, what would you look into to predict whether it's going to rain or not? And which factors would you consider? Which factors would you ignore? So the things that you would ignore, you would remove it from the training data and give it to the model. Think yourself as the machine or the machine learning or the algorithm, your brain, which in fact it is. Think yourself about it and then give the same information to the computers or to the machine learning. How do you manage it? Again, as I said, regularization, use different techniques to penalize the model if it predicts the wrong data. Cross validation, use different subsets, different testing data. Data augmentation, create new training data sets from existing samples and help reduce overfitting. Choose the right model complexity, which means remove the irrelevant data from the training set. So example of high bias. So let's say if you have data set of student exam scores and the corresponding hours of study. So now if to predict the exam score, if you just depend on number of hours of study, it's underfitting, right? Because that is just not factor which determines what your score would be. There are so many things that number of hours of study, but how much focus you did, how much practicals you did. There are so many factors that go into predicting your scores. How well you are well versed with the course. All that determine the relationship. Okay, so just having one parameter like number of study hours to predict the exam score is underfitting. So bias means you use linear regression, which is too simplistic. So if you look in previous videos, linear regression is just using one feature to predict the other. Okay, so the effect would be the model will have high bias and will perform poorly, both in training data and testing data. Okay, so to reduce this bias, again, what you could do is consider giving more features, making the model more complex, such as multivariate regression, which was also taught in one of the previous lectures. Now, example. So let's say if we continue with the same example, you decide to use a very complex violence. Now, this is example of high variance. Okay. Now, to predict the exam score, what do? You do a high degree of polynomial regression. You put in factors which are not needed at all. So let's say how fit the student is, or what do you say, the number of hours the student watches TV versus number of hours the student watches news. That might not have direct impact on the scoring, right? So you should not use those. So variance is very high degree of polynomial factors, like things that are not needed, you add it to the complexity of the data. So what happens that in training data, even if it does really good, if you give it the testing data and you twist a certain number of parameters, the output would differ widely. Okay. So balancing bias and variance involves finding a model that adequately captures the underlying pattern of data. So first you got to be clear in your mind what you think. But then don't just stop there. Play a little bit with the training set data. Like add one more feature and see how the model performs and see the variance, right? So it's not like in first attempt you're going to get everything right. It's all trials and errors. You got to train your model multiple times until you get the least error. So how do you compute bias? So find the difference, like what is the actual value and what did the model predict, the difference between them. It's also called as mean squared error. Variance is also computed that way. If you vary one parameter and if you see how much difference is there between the actual value and the predicted value, you'll come to know. So here mathematical formula 1 by n, which is n is the number of data sets, sum of the errors, actual value minus the predicted value squared. Okay. And variance 1 upon n, sum of the predicted value minus mu, which means the prediction across all data sets, raised squared. So what is the interpretation? If the bias is high, the variance is low. The model is underfitting. If the bias is low and variance is high, the model is overfitting the data. If both are high, the model is both underfitting and overfitting the data to some extent. But if both are low, it is the perfect model, well-fitted model that we are looking for. So that is all for today. Hopefully the concepts when somebody says bias and variance is clear to you. Hopefully now, if you're already using some model or doing some testing or something, look into the data and see how it is affecting the predicted value. All right. Thank you all for your time and attention. See you all again in the next lecture with some new concepts. Until then, take care. Bye.